What is up, year 3? Welcome back to the Maths Guy. This is the first of a lesson series covering everything you need to know for year 3 mathematics. Today we're starting on lesson 1, which is place value. Let's waste no time, let's go. Okay, so our first lesson we're going to look at in place value is how to count in multiples. Are we ready? Rock and roll, let's go.
Okay, so let's remember that multiples are numbers that are in the times tables. And today we're going to focus on these 4 numbers here. We've got number 4, 8, 50 and 100. So let's start with number 4. And what we're doing is we're trying to find numbers that are in the 4 times table. So 4 would be the first one because that's just 4 times 1. But what's the next one? What happens when we get to times 2? Well, all we're doing essentially, we're doing 4 plus 4. And 4 plus 4 equals 8. So the next number in our multiples would be 8. 4 times 2 is 8. And if we're timesing it by 3, all I need to do now is 4 plus 4 plus 4, which is 4, 8, 12. So I have an answer of 12. So therefore, my next multiple would be 12. Because what we should notice is all of these jumps are just adding on 4. So therefore 12 adding another 4 becomes 16. And then 16 adding 4 would get to 20. And when we're talking about multiples, we can actually theoretically go on forever. I could end up with 400, for example, and then the next one, add 4, could be 404. So our multiples can just keep going infinitely. Let's have a look at our multiples of 8. It's exactly the same strategy. All we're going to do is find the next 8 by plussing 8. And 8 add 8 equals 16. So therefore my next multiple would be 16. 16 add 8 would be my next one, and that equals 24. And then to find the next one, all I'm going to do is continue adding 8. 24 plus 8 equals 32. So our first 4 multiples of 8 would be 8, 16, 24, 32, and then our next one would actually be 40, then 48, 56, 64, 72 and 80. But remember, we can go on forever. There is no end. Now we get to a few more challenging ones. We're going to have 50, which sounds like a huge number, but actually 50 is pretty easy to understand because 50 is made up of 5 tens and 0 units. So therefore together I like to call it a happy number because we can put this smiley face in the 50, and the reason it's happy is it's quite easy to manage. We could even forget about our happy face and just think of it as a 5 for now and do 5, 10, 15, 20, 25, and then put back our happy face. So it'll be 50, 100, 150, 200, 250. That could be one way you could solve this, or we could just think 50, 100, 150, 200, 250, 300. It's pretty easy to add up because we're just working with 50s. So therefore the first 5 multiples of 50 would be 50, 100, 150, 200 and 250. But don't forget, these could go on forever. And last but not least, let's look at 100. 100 is actually probably the easiest on this list because we have 100, then 200, 300, 400, 500. These are all multiples of 100. And let's just remind ourselves that we know it's a multiple because 700 is in the times tables of 100. They have a relationship. We would times 100 times 7 in this case equals 700. So we have our number, we're multiplying it by another number, and we get 700. Therefore 700 is a multiple of 100. It's also a multiple of 7. But we'll get to that in another lesson. Let's look at what to remember. When we multiply a number by another number, we get a multiple of both of those numbers. In other words, multiples are numbers in the times tables. Your turn. Can you write the first 10 multiples of each of these numbers? Put your answer in the comment section. I'm going to mark them all. Good luck. Press pause now.
Okay, so now we've mastered multiples, let's look at how we can find 10 and 100 more than any given number and why that can be really important for us. Let's go.
Okay, so the thing we're going to remember today is that we're going to create a place value chart to help us. Let's see what that looks like with our first example, which is this number here, number 56. So we're working with the number 56. Our tip said to use a place value chart. So when I'm making a place value chart, I'm going to have my 1s above my 6 and my 10s above my 5. Sometimes you might have heard of this 1s being called units. That's fine as well, they mean the same thing, 1s or units. Okay, so now I can look at my number and analyse it a little bit and see that I have 6 1s and 5 10s. And if I want to try and find out what 10 more would do to this number, so let's do 10 more. All I have to do is look in the tens column. And at the moment, I have 5 in the tens column. If I want to go 10 more, I'm going to be adding 1 10 to this column, because this is my tens column. At the moment there's a 5, so if I want to go 1 more, I would go to 6. That's adding 10 to my number, 1 10 to my number. I've done nothing to my units or my 1s, so therefore I can bring this other 6 down, and my answer to 10 more than 56 is 66. Let's do not 10 more, but let's do 10 less, and let's see what happens. So again, which one do we need to look at? Well, we're going to be looking at our 10s. And at the moment, I have a 5 in the 10s, so I have 5 10s. If I want to have 10 less, or a 10 less, I'm going to get rid of one of these 10s and put it down to a 4. So now that I have this 4, I can then look back into the 1s column and see that I have a 6. Bring that down because we're not changing anything in our 1s column, and my final answer is 46. So 10 less than 56 is 46. Okay, let's have a look at a bigger number. Let's have a look at example 2, 145. So I have 145, and now let's remember our tip again, which was to create a place value chart to help us, which means I'm going to put my 1s or units, 10s, and now hundreds over the top. Now I'm going to look for what 10 more would look like. Well, which column am I going to focus on with 10 more? I'm going to be looking in my 10s column. And at the moment, I have a 4. And if I'm going to be adding a 10 to my 10s column, that's going to turn into a 5. I didn't do anything to my 1s column, so I can bring that down. That's another 5. And I didn't do anything to my hundreds column, so I can bring that 1 down. And my new answer to 10 more than 145 is 155. Okay, but what about 100 more? Let's have a look what that looks like. Well, now we're looking for 100 more. Which column am I going to look at? Not my 10s column anymore, because that's 10s. I'm going to look at my hundreds column. So now I can see I have a 1 in my hundreds column, and if I'm adding 100 more, I'm going to add 1 to my 1, which equals 2. I didn't do anything to my 4 in the 10s column, and I didn't do anything to my 5 in the 1s column. So my new answer to 100 more than 145 equals 245. Okay, but what about 100 less? Okay, well, let's do the same thing. We know we're looking in our hundreds column, and I can see I have a 1. So this 1, don't forget, is a 100. What is 100 less than 100? Or in other words, 100 take away 100? Well, that's 0. So I end up with 0 in the hundreds column. I can bring down my 4 from the tens column and bring down my 5 from the ones column. So my answer is 0 hundreds and 45, or in other words, 45. Okay, let's look at our last example, 439. A huge number. And let's have a look what 10 less looks like. So let's remember, always put our place value chart in place. That's going to help us remember how to do it, but also help us remember which column we're going to be working on. And if we're working on 10 less, I'm going to be in my tens column. And at the moment I have 3 tens, or in other words, 30. So what is 10 less than 30? Well, it's 20, or 2 tens. I bring down my 4, and I bring down my 9, leaving me an answer of 429. So 10 less than 439 is 429. Let's do 100 more. And I think you're starting to get it now. We're going to look in our hundreds column, and I can see I have a 4, or in other words, 400. So my question is 100 more than 400, or 4 hundreds adding to 100. So I'm going to end up with 500. And I bring down my 3, I bring down my 9, and I get a final answer of 539. Simple! Let's look at what to remember. Start by creating your place value chart. This is really important. It will help you understand which column we are adjusting. Line your numbers up into the correct columns, and then focus on the column that is the one you're working on. If you're looking at 10 more, you're going to be working in the tens column. If you're looking at 100 less, you're going to be looking in the hundreds column. And in the future, when you're looking at bigger numbers, when you're looking at 1,000,000 more, you'll look in the millions column. So this is a really good practice to get into the habit of. Here you go. Here are 3 numbers for you to have a go at. Find 10 and 100 more and less than each of these numbers. Have a go at working these out on some paper. Take your time. Press pause on the video now. Good luck.
Okay, good. We're into the flow of things. Now let's start to really dive into the depth of place value and start to understand and recognize the place value of digits in large numbers. Ready? Go!
Okay, and what we're going to try and remember today is to use a place value grid to help us. But first of all, what do I mean by a 3-digit number? Well, if we look at this number here, 725, we can see that it's made up of 3 digits. We have the 5, the 2, and the 7. And each of these digits has a value. And we use the place value grid to help us understand what value. So let's put our 725 inside our place value grid to see what value each of these digits holds. So our 5 would go inside our ones column, our 2 would go inside our tens column, and our 7 will go inside our hundreds column. Therefore, what we're saying is that we have 5 ones, 2 tens, and 7 hundreds. So therefore, another way that we could look at this number is to partition it, which means to break it into its place value parts. So we could say I have 5 ones, 2 tens, which would be 20, and 7 100s, which would be 700. So 725 has the same value as saying 700 add 20, add 5. So what we can do is just look at our 725 and create our own place value chart above it. We can say I have 5 ones, 2 tens, and 7 hundreds. And organizing your work and your numbers like this with the place value signs over the top is a really good habit to get into the habit of now, because when we start to look at addition and subtraction, we're going to put those place value titles on top so that we make sure we put numbers in the right columns. But for now, it's really important to understand that this 2, for example, is not a 2 because it's in the tens column. It actually represents 2 tens, which equals 20. And the 7 is not just a 7, it's actually 7 hundredths, which equals 700. But our 5, because it's in the ones column, actually only represents 5 ones, which equals 5. And what we should always find is that when we've broken our number down like this, when we add it back together, we should end up with the same number. And 700 plus 20 plus 5 equals 725. Let's have a look at another number. Let's have a look at 356, and let's do exactly the same thing. But let's start by putting our titles on top ourselves. So my 356 is made up of 6 ones, 5 tens, and 3 hundreds. So now if I put this number into our place value chart, I can see I have 6 ones, 5 tens, and 3 hundreds. And again, just like before, I can break this number down by partitioning it, which means breaking it into its place value sections. I have 6 ones, 5 tens, which is 50, and 3 100s, which is 300. And again, I should find that if I add these together, I should equal the original number, and 300 plus 50 plus 6 equals 356. So in other words, I have 3 hundredths, which equals 300. I have 5 tens, which equals 50. And I have 6 ones, which just equals 6. And again, adding these together will always equal my original number, 356. So the really important thing to learn today is that even though this looks like a 5, it's not just a 5 because it's in the tens column. It actually has the value of a 50. And that this 3 in the hundreds column isn't just a 3 because it's in the hundreds column. It actually has a value of 300. And because our 6 is in the ones column, it has a value of only ones. So 6 ones is just 6. Understanding how to use a place value chart is super important because when we start to look at addition and subtraction, we're going to make sure that we put our numbers in the correct column by putting them in our place value parts. Now, I just want to show you something. Let's imagine we're not looking at this number for a moment, and let's say I put a 1 into our ones column. Well, the value of our number at the moment equals 1. But if I move my 1 into the tens column, then I end up with this gap in the ones column. And I can't just have a gap in the ones column, so I put what's called a placeholder in there. Because now my 1 is in the tens column, I have nothing in the ones, so I'm filling it with this placeholder. And therefore, my new value equals 10. And if I do the same thing again, I move my 1 into the hundreds column. Again, now I'm left with this gap in the tens column, which now needs to be filled with another placeholder. I end up with 100. So just moving my 1 from the ones into the tens into the hundreds makes the value of my number go from a 1 to a 10 to 100. And what we might notice is that getting from 1 to 10 means that I'm timesing by 10. And then to get from 10 to 100, I also times by 10. And that's because every column on my place value chart is 10 times bigger than the last column. So anything in my ones column, for example, if I put a 5, if I then move it into my tens column, it has 10 times that value. Originally it was just a 5, and then I've moved it into the tens column, and it now equals 50, which is 10 times larger. And the same thing from going from my tens to my hundreds column. It's 10 times larger. So if I move this 5 again into the hundreds column, it becomes a 500. 500 is 10 times larger than 50. Wow, that's an interesting little fact, isn't it? Okay, let's look at what to remember. First, we can see the value of each digit by putting it in the place value chart. place value charts are super important and are going to become your best friends. And each column is 10 times bigger than the previous column in our place value chart.
Awesome, so now we've looked at a little bit of place value and their value of each column. Let's now look at how we can order and compare numbers using this place value knowledge. Let's go.
Okay, so our top tip of what to remember today is that we're always going to try and use a place value chart to help us. So let's start by ordering some numbers then, and we have these two sets of numbers. We have set A and set B. So let's first look at set A. We can see we have 678, 628 and 652. And when we're thinking about ordering numbers, we have two choices. We can either go from smallest to largest, and we call this ascending, which has got a horrible spelling, A-S-C-E-N-D-I-N-G, or we can go from largest to smallest, and that way we call it descending. Another tricky spelling, D-E-S-C-E-N-D-I-N-G. So we have these two options. Today we're going to focus on ascending, going from smallest to largest. But how can we look at these three numbers and see which one is the smallest and which one is the largest? Well, like our top tip said, we're going to use a place value chart to help us. So we're going to need our ones, our tens, and our hundreds, and then we're just going to put the numbers in place. I have 678, I have 628, and I have 652. And now we need to understand some things about our place value column. We need to understand that our smallest column is obviously here, our ones. So whatever's in our ones has the smallest value. Then we have the tens, our next smallest value, and then our largest value we have as hundreds. In fact, when we go from column to column, we're actually getting 10 times larger. So a 1 in the tens column is worth 10 times a 1 in the ones column. And again, 10 times larger in the hundreds column. And when we're comparing numbers, what we want to try and think about is everything in the largest value column. So in our case here, we have hundreds. That's our largest column. This is the most important column because, for example, if we had a 5 in here, we would automatically know that this number would therefore be the smallest because 500 will always be less than 600, and therefore it doesn't matter what happens after the number, because 528 will always be smaller than any 600 number. But in our case, we unfortunately have 3 6s, so that doesn't really help us. So now what we'll do is look in the next biggest value, which is our tens, and now we can see some differences. I have a 7, a 2, and a 5. Well, which one's our smallest? Well, obviously, a 2 is smaller than the 5 and the 7. So therefore that automatically means that this number here has to be smaller than either of the other two, because the 2 in the tens column can never be greater than the 7 in the tens column or the 5 in the tens column. So therefore our smallest number in this case is 628. So I'm going to write that here. 628 is our first one. What's our next smallest value? Well, that's right, we have this 5. Therefore the next smallest number would be this number here, which is 652. And therefore, the biggest number is 678. Awesome. Let's use that same tactic for the next set of numbers. And let's start by putting them in place. There we go. And again, I'm going to look in this first column, and I can see that they're all 5s, so that doesn't help us. Now when I look in the second column, the tens, I can see I have 2 2s. So now I can ignore this 9 for a moment because I'm just comparing the 2s, and I'll look in the column next door to see which one has the smaller ones, and we have a 3 here. So therefore my smallest number is 523. My second smallest would therefore be 524. And the only number that had a 9 in the tens column is our 592. So both of these sets of numbers are in ascending order, going from smallest to largest, and they've been reordered. So that's ordering. Let's have a little look at comparing. And I'm going to compare these sets of numbers. You can see I've got this little versus sign here. Now when it comes to comparing, we're going to learn three very important little symbols. We're going to learn this symbol here, which means greater than. We're going to learn this symbol here, which means less than, and we're going to learn the equal sign. So first of all, why does this mean more than or greater than? Well, that's because any number on this side will be bigger than any number on this side. And a little way to remember this is to try and think of this little symbol as a crocodile. And imagine it with its big shiny teeth. It's going to want to eat the bigger number. It's a hungry crocodile. So therefore, looking at this symbol here, which is less than, means anything in front of the symbol will be less than anything after the symbol. So 5 is less than 8. And that's correct, isn't it? 5 is less than 8. And again, if you look, the crocodile is facing the bigger number. And our equal sign simply means equals. It means that what's on one side is the same as the other side. So let's put our three symbols up here just so that we remember them. And let's begin. And I'm going to look at my 678 versus 628. So I have 678 and 628. Well, what am I going to do to help me? That's right, I'm going to put them in my place value columns again. Ones, tens, and hundreds. And let's bring this number down below. 628. Now when I'm comparing, I'm trying to see which one is greater. And I can see that they have a 6 in both of these columns in the hundreds. But in the tens, I have a 7 and I only have a 2. So therefore our 678 is larger than our 628. So that means 678 is bigger than 628. So how would I show that? I can't put an equal sign because they're not equal, so I'm going to have to use one of my crocodiles. Well, which one am I going to put it with? That's right, I want the crocodile to face the bigger number. And 678 is larger. So for my first one, I'm going to use the symbol greater than. Let's look at our second example. I have 291 and 173. And straight away, I can see that in the hundreds column, I have a 2 and a 1, which means this value here is always going to be larger. So that means the 2 in the hundreds column will always be bigger than anything that now can come from my second number. Therefore, this is my greater number, my greater value. So again, 291 is greater than 173. Remember, the crocodile wants to eat the big number. Last but not least, I have 999 and 692. And I can simply see in the hundreds column I have a 9 and a 6, meaning that my 9 will always be bigger than my 6. And therefore, again, just like the other two, I have a greater than symbol. Let's have a bonus one. Let's have 352 is greater than, smaller than, or equal to 526. Well, I don't even need to do it with my place value chart because I can just see that in the hundreds column I have different numbers, so therefore the 5 will always be greater than a 3, so therefore this number is larger and my crocodile would rather eat that number. So my number sentence reads 352 is less than 526. And that's how to compare numbers. What to remember? Well, first we're going to start by always creating our place value chart. Place value chart really helps you understand how to order and compare. Then we're going to line up our numbers in the correct columns and then focus on the column that we want to work on. For example, we need to know the hundreds column is the greater values. Therefore, we'll start by looking at our greatest value column first. That's the important one. What is up everybody and welcome back to the Maths Guide. Today we're looking at how to write numbers into words. So let's jump into it. Okay, so what we're going to remember today is that we're going to group our numbers first. So let's have a think about what that means with our first example, 723. So the first thing I'm going to try and do is group my numbers. So I can see that I have a 6 block place value chart here, where I have 1, 2, 3, 4, 5, and 6 available slots. But we of course only need 3. This is a 3-digit number. So I'm only going to be working in this first block, nicknamed the ones, first of all. And in this first block, I actually have my ones, tens, and hundreds. Hopefully you've seen that before. So in 723, I can see I have 3 ones, 2 tens, and 7 hundreds. And because we're only in this first block, we don't need to think about thousands at the moment, so we can simply say what we see. So I have 723. So I'll put this little and symbol to remind me there's an and there. So when writing this number into words, all I would have is 700 and, don't forget that, and 23. Awesome. A simple one to get us started. Let's have a look at a more challenging one, 6,723. So this time we actually have a 4-digit number, so I'm going to be using 1, 2, 3, 4 of our available slots. And this time I can see that I'm going to use my ones, my tens, my hundreds, and the first one of our thousands. So when putting this number in, I can see I have 3 ones, 2 tens, 7 hundreds, and 6 thousands. Now let's think about our groups again. Remember, we're grouping our numbers, and I can see in my ones group, and now I have something in my thousands group too. So this is really important now, because I'm going to say what I see in each group first. And in my thousands, I can see that I just have a 6. So the start of my answer will be 6,000. And now I come to the next group, my ones. And in the ones, all I can see is I have a 723. So I just simply write that, 6,723. So the only extra part of this question was this thousands part. And we had a 6 in the thousands, so therefore I put 6,000 at the start. Let's turn the heat up a little bit more and look at something even harder. Whoa! Now I can see I have a 6-digit number. So therefore I'm going to be using all 6 columns in this place value chart. Of course we could go bigger and have even more columns into the millions, the trillions, but we're not going to today. So now I can see I'm going to need my ones, tens, hundreds, thousands, 10,000s, and 100,000s. And I can see with my number I have 6 ones, 7 tens, 8 hundreds, 7 thousands, 5 10,000s, and 6 100,000s. So again, let's think back to our tip of grouping our number first, and we're going to group our numbers into our ones and our thousands. Now I want you to notice something here first of all. We group in groups of 3. We can see we have 3 digits to the ones, and we have 3 digits in the thousands. If I was to have another column here, this would start our millions. And I'd have a millions column here, 10 million, 100 million, etc., etc., into my trillions. So we group in sets of 3. And that's why we use this comma here. You can just see that comma to separate the number even when we write it down as digits. That helps us remember that this 873 is in a different group to the 657. These are my ones, these are my thousands. So again, all I need to do at this point is say what I see. And I can see here 657. And what group are we in? We're in the thousands. So I have 657,000. Because remember, we're in the thousands column. Then I can put my comma, 876, because 876 is what I can see in my ones column. And that's about as hard as it can get. It could get longer. We could come into our millions, and I could have my millions here. So let's write a number including my millions. Let's have 25,322,126. But again, all I have to do is group my numbers into 3, starting from the ones. So I have 3 digits here, I have 3 digits to my thousands, and I don't quite have 3 digits in my millions, but that's fine. But therefore, it's really important to remember that we must always group from our ones first, because if I group 3 numbers here, starting from my millions, I would end up getting it wrong, because look, I come across the wrong groups, and I don't have 3 at the end here. So when we're grouping, it's really important to remember, start to group from the ones. Okay, well, let's write what we see. Starting with our millions, how many millions do I have? I have 25, so 25 million. How many thousands do I have? I have 322, so I have 322,000, another comma, and then what do I have in the ones? 126. And there we go. And honestly, that is as hard as that can get. It can get longer. We could go into our trillions, but it can't get much harder if we remember this pattern of starting to group our numbers in sets of 3, starting from the ones column. Simple. Let's look at what to remember. To write a number into words, we can partition it or group it first into sets of 3. Commas can really help you to split the number and help us to understand the sections or the different groups. Okay, so your turn. Have a go at writing this number here into words. First, think about where you're going to find your groups. There's a big clue here because we have the comma. And write your answer in the comment section. I'm going to try and mark every single one. Press pause on the video now. Good luck.
And our final lesson, we're going to start to look at partitioning numbers and understanding how partitioning numbers helps us to start to move into things like addition and subtraction. Let's jump into it.
Okay, what are we going to remember today? We're going to remember to use our place value chart to help us. So let's have a go at this first example with the number 24. Well, first of all, what does partitioning mean? Partitioning is a fancy word for breaking up our number into more manageable, easy parts. So we have the number 24, which is not a big number, but it's a good starting point. But still, 24 could be quite difficult to use in a mathematical question. Say, for example, we had 24 times 24. Well, that would be very hard to work out. So we have a strategy. We have a strategy of partitioning the number. So I can partition my 24 by looking at it as 4 ones and 2 tens. So when I'm partitioning, I can split my 4 ones into just a single 4, and I can split or partition my 2 tens, which would be 20. So my partitioned version of 24 would be a 20 and a 4. Simple, right? And I can always make sure I partitioned it correctly by just adding these sections back together and see if we get back to the original number. So 20 plus 4 equals 24, and 24 is the same as my original number, so I know I've done that correctly. Let's move to a slightly harder example, 749. So I can see with my 749 that I have 9 ones, I have 4 tens, and I have 7 hundreds. So therefore, when I'm partitioning, I can break this down into 9 single ones, 4 tens, which would be 40, and 7 hundreds, which would be 700. Let's make sure I've done that correctly by adding them all together again and seeing if I get back to my original number. 700 plus 40 is 740, 740 plus my 9 equals 749. Is that the same answer? Yes, it is. We've done it correctly again. Okay, let's have a look at a real challenge. Let's have a look at a big number like 252,512. Whoa. Can we even partition a number like this? Well, yeah, it's just going to take a little bit longer. Here we go. Let's remember that this number also will have our titles. So I have 2 ones, 1 10, 5 hundreds, 2 thousands, 5 10,000s, and 2 100,000s. And let's just look back to our thing to remember to use the place value chart to help us. This is our place value chart, and you can see how it helps us, can't you? Because we're breaking it into those sections. Okay, so let's begin partitioning using my ones first of all. I'm going to try and get as much room as I can, so I'm going to come all the way over here. How many ones do I have? 2 single ones. Let's look at my tens column. How many tens do I have? I have 1, so that would be a single 10. How many hundreds? Well, I have 500. Let's now look at our thousands column. How many thousands? I have 2. So I have 2,000. How many 10,000s? I have 5. So I don't have 10,000. I have 5 of them, so therefore it would be 50,000. And then my last one, how many 100,000s do I have? I have 2, so I have 200,000. Whoa, look at that. And again, I can check by just adding these all together to see if I got the correct answer. Or sometimes you can just read it from left to right to see if you got the right number. Let's do that. 252,512. Awesome. And a super difficult one. But why is partitioning numbers helpful? Well, let's have a look again at a simple one. Let's have a look at 25. And I'm going to break it into a 5 and a 20. And let's imagine I had a question like 25 plus 73. And I didn't want to do this using column method. I wanted to just do it quickly in my head or using a different strategy. So I could get my 73, and I can remember that that is now a 3 and a 70. And now all I would need to do is add these numbers together, which would be much easier. And I'm going to do this in a strategy. I'm going to add my 20 to my 70. That equals 90. Then I'll add my 5. That equals 95. Then I'll get my 95. And I'll finally add my 3. And that equals 98. So partitioning numbers is an awesome way to help you do things like addition or even multiplication. But we'll get to that in another lesson. Your turn. Have a go at partitioning this number, 7,521. Use the same strategy, partition the number, and put your answer in the comment section.
Awesome, there you go. That was place value. That was our first lesson in our year 3 lesson series. Make sure you check out the next video, which is going to be addition and subtraction. But for now, guys, I'm going to see you in another video. Peace out.